What's up, Arc Junkies? Welcome to show number 291. Joining me today for the first time is David Kilburn, Director of Flexible Automation for Europe at Lincoln Electric, and returning guest Nate Bowman. Nate mentioned David last time he was on the show, and since that episode, I was able to connect with him. David started his journey with massive, thick sections of pipe running SubArc, and he's now on the complete opposite side of the industry doing thin, fast laser welding. David also volunteers his time to help build hospital beds in Malawi. David's a super cool dude with an awesome story, and we're going to get right into it after a quick word from our supporters. Today's episode of the Arc Junkies Podcast is brought to you by Outlaw Leather, a family-owned custom hood and leather welding accessory company based in Pasadena, Texas. Outlaw has everything you need as a welder to help you stand out and get the job done. They specialize in quality and hand-build each custom piece to order right there in their shop. Whether you're in the market for a welding hood, rod pouch, or an armband for pipe welding, or you're an iron worker that needs a custom tool belt, bolt bag, sleever bar holder, or pig ears, Outlaw's got you covered. If you're looking for custom pieces, just shoot them an email, info@outlawleatherllc.com, and they'll build your custom pieces to your exact specifications using your original designs or artwork. Maybe custom isn't your thing, or you just need to get some gear in a hurry. Not a problem at all. You can shop outlawleather.com directly and get fast, easy shipping right to your home or your shop. And as a listener of Arc Junkies Podcast, you can save 15% off all in-stock handmade leather goods when you use Arc Junkies in the discount box at checkout. And if you're local to Pasadena, just stop in their storefront and they'll treat you like family. Tell them the Arc Junkies sent you. We're also brought to you by Fronius USA. Fronius is thrilled to announce 2 new products to unleash your welding potential. First up is the Fronius Dual Wire Feeder. The new WF25i gives welders the freedom to have 2 torches ready to go, each with different wire types, different welding parameters, diameters, and easily switchable at the touch of a button. No need to change wire spools or consumables between applications. Get precision wire feeding and save time without adding complexity to your day. Next up is the new mobile fume extraction system, Accento. The Accento comes in both high-vac and low-vac versions to fit your specific welding needs. The low-vac system includes a flexible extraction arm with 360 degrees of rotation and a flow-optimized hood for an exceptional fume capture rate. The high-vac system combines perfectly with the Accento torch kits to remove more than 99.9% captured fume particles at the arc to provide excellent extraction in a compact unit. Come experience both product lines at FabTech this September in Chicago. And while you're at the booth, be sure to stick around for daily machine giveaways, guest appearances, welding presentations, and of course the opportunity to weld on-site with a wide range of Fronius products. We're also brought to you by Rockmount Research and Alloys. By now, you no doubt know about Rockmount's awesome rods and wires for dissimilar metals, welding through hydrocarbons, and getting higher performance at lower amps, but that's not where Rockmount's catalog ends. They have everything you need for all of your fabrication and repairs, like laser best drill bits, cut-off wheels, flap discs, hard rocks, drill bits, threaded inserts, stud extractors, reamers, and more. This is top quality stuff. I've used several of their burrs and grinding discs and they all perform great. One of my favorite wheels that they put out is the PSP. It's specifically designed to prep, shape, and polish with one wheel. This disc is ideal for going from weld to paint with one wheel. No more swapping out different grits to get to a paint-ready surface. Just use one of these bad boys. And right now, you can save 10% when you shop for all your metalworking abrasives and consumables when you go to rockmountwelding.com and use Arc Junkies 10 at checkout. Get the job done right the first time, every time with Rockmount. We're also brought to you by Underground Metalworks. Unleash the power of welding with Underground Metalworks in Orlando, Florida. Whether you're a newbie or a pro, get hands-on with our short-term welding training. We offer small class sizes with a 5-to-1 student-to-instructor ratio. Dive into our week-long comprehensive course or opt for an evening and weekend session. Master the art of stick, MIG, and TIG welding in no time. Classes are affordable, expert-led, and tailored just for you. Visit undergroundmetalworks.com today to see a full list of classes, schedules, and prices. We also offer corporate training to bring your team up to par to knock out that next big job. Ignite your passion with Underground Metalworks. All right, everyone, FabTech is just around the corner, and if you're planning to attend, there's a couple after-hours events that I wanted y'all to know about. Join me and a few of my friends Sunday, September 10th from 7 to 10 p.m. at Hard Rock Cafe, Chicago. This event will be hosted by some of the biggest names in the industry to include Weld Porn, Blue Demon, Outlaw Leather, O2 Armor, Up and Smoke Welding Apparel, Kalos, Fronius, Flametech Scorpion, Weld Metals Online, Arc Junkies Podcast, Underground Metalworks, and Southern Weld Company. Then, On Tuesday, September 12th at Fat Pour Tap Works, you can join me and Stephanie Hoffman for the American Welding Society's Arcs and Ales networking event. If you've ever been to an Arcs and Ales event, you already know you don't want to miss it. Also, on September 30th, you can join me up in Green Bay, Wisconsin for Viper Fest at Viper headquarters. Viper Fest includes a car show, a burnout pit, private car detailing, and welding classes, and to wrap things up, a concert featuring Smoke Road and Our Last Night. Tickets are available at viperfest.com. Just click on the link in the show notes. All right, you know what time it is. Fire up your machine, drop your hood, and turn me up 5.
Thank you for downloading show number 291 of the Arc Junkies Podcast.
You're listening to the Arc Junkies Podcast, helping you make every weld better than your last with each episode. And now your host, Jason Becker.
All right, so joining me today is my buddy Nate Bowman and now David Kilburn. Guys, welcome to the show.
Thank you.
So, Dave, I got to meet you via LinkedIn because Nate name-dropped you on the last episode that he was in. And I think everybody got to chatting in that little comment section, and everybody's like, you guys have got to have David on. So I was like, okay, yeah, sounds like a good time. Let's do it. So we reached out, had a little bit of conversation. And, David, you've got a pretty interesting background. So let's start off. You've been with Lincoln for, what, 15 years?
Yeah, 15 years now.
Nice. Yeah. Okay. Now, how'd you end up getting started? Were you welding prior to linking up with Lincoln Electric?
No, I knew nothing about welding. I started as an engineer at Grove City College. My senior year, one of my buddies told me, hey, you need to go look at Lincoln. I wasn't really an engineer per se. That wasn't who I was as a persona. It was more talking to people. And that's really my passion, even outside of welding, even today. And yeah, long story short, it led me to Lincoln and around the world a couple times in the last 15 years. And here I am. But to answer your question, I didn't know anything about welding. As soon as I interviewed with Lincoln, I went and signed up for a welding class and realized, oh my goodness, what did I get myself into? Because I knew nothing.
So I think that's probably the best part about David is, you like 15 years. This was 15 years ago, and how far you've come in 15 years, and now you're working on cutting edge stuff. And I've mentioned this. This is why I mentioned having you on the show. It's the people that don't think inside the box that are dangerous in the industry.
Well,
in a very good way.
Labeled as dangerous, but I think you're probably right, Nate.
In a very good way.
Yeah, I've heard, David, you're a little bit disruptive, but in a positive way.
I'm not sure who told you that, but yeah, maybe. I mean, look, a quick summary is, I went into the sales field. I just ask a lot of stupid questions because I don't know what I'm doing and want to figure out what the customer is actually trying to achieve. So I'd say the first 10 years, actually 14 years of my career were fully focused on SubArc stuff. So really, really big welds. I'm talking about like 5,000 plus amps in one puddle. And then recently, within the last year, transitioning that to really, really small welds, electric vehicle battery trays, like super fast. Nate, you're going to have to help me with a conversion here, but like 8 meters a minute travel speed aluminum welds that apparently knocked his socks off. I just thought it was kind of cool.
Yeah, that's pretty damn fast. Nate's working on the conversion right now.
I am. It's yeah, hang on one second. Oh, it's 26 feet. So 8 meters a minute. So 20, is that right? 26 feet a minute?
Yeah, per minute. Yeah, that's right.
Damn, how many inches is that?
26 times 12. Sorry, doing math here. 144?
140. Right? Jeez. That's linear inches per minute.
No, 312. Sorry.
Okay, 312.
Yeah, no, it's 300 plus if I remember right. Yeah.
Yeah, because this was the one that really, here I am thinking I'm fast doing hyperfill at 18, 20 inches a minute, and you're welding aluminum at 300.
David's like, hold my beer. I got that. I got that all day.
Go ahead.
I was just gonna say, so when you started off doing SubArc, I mean, you went through the Lincoln Welding School and everything, and then started working on SubArc. That's a completely different process to learn. So that's one of the things I like about SubArc is it's kind of super simple once you understand, like Nate always says, what the knobs and dials and stuff do, because you're taking the human, other than the programming side, you're taking the human element out of that. So now you're relying on a machine to maintain travel speed, contact tip to work distance, all that good stuff. But once you understand the variables as far as volts, wire feed speed, travel speed is huge, we know, when it comes to welding, especially in a SubArc application, because you can burn through stuff really quick or not get enough penetration. So going into that, how do you start incorporating multiple heads into a SubArc system?
So to summarize very quickly, there was an offline spiral pipe mill, and that sounds very specific because it is, but basically people that make really, really big pipe. So think 36 inches in diameter, 72-foot lengths. I mean, Keystone XL, Blue Ridge Parkway. I mean, all these large pipelines across the U.S. This was one of the companies that was supplying the pipe to that, and they needed some help. And I had no idea what I was doing. I didn't understand SubArc more than the simple constant current versus constant voltage thing. And now I've got 3 arcs on the OD, 2 arcs on the ID, some complicated brush grounding system. And I had no idea what I was doing. But every day I would get on a phone call with corporate Cleveland and then some of our technical resources here in Europe. And I was like, hey, when you see porosity or outgassing on the top of a 3-arc weld, what do I need to look at? And I would walk into the shop every day, perfectly confident that what my team had told me was right. And I was more or less just a messenger. I was like a pigeon, right? There was no value for me other than being the guy to deliver the message. And so we'd go to the shop, we'd try it, and we'd get a little better. Or maybe we'd get a little worse and we'd try something else. And so we troubleshot that pipe mill for, a year. And we broke, Jason, just to be honest, full disclosure, we broke everything in that facility. I learned from failure, and so I've learned a lot. Everything from the forming process to the hydropressure testing process, we broke everything only because I was the guy that didn't know to say stop. So I just tried it, we got up and running, and that's really where I cut my teeth, if I can use that phrase, in SubArc, and that transitioned me into a global role, into more pipe mills. I mean, there's only about 40 pipe mills globally in the world, people that make really, really big pipe. So from about 2012 to 2018-ish, I flew around the world visiting these customers, troubleshooting their pipe mill problems, not because I inherently knew what the problem was, but I had broken a lot of things in my past, and I knew what to avoid. And I also knew who to call to say, hey, this is outside of my repertoire. Now what do I try?
Yeah, sometimes it's actually more helpful to know exactly what not to do than what to do.
Yeah.
Yeah, so like, I mean, if you're going through and you're experimenting with a lot of this stuff, if you're not sure, what's the problem? How are we going to fix it? I mean, you've got to start playing with the equipment. Let's see what this equipment can actually do. Let's see what the variables do. Let's turn the knob all the way one way and see what that gives us. Okay, let's turn it back the other way and see what happens there. And then we can start fine-tuning and doing all the adjustments and everything and avoid a lot of the problems that we're coming in contact with.
Yeah, I mean, everywhere I've ever gone, they always say this is the problem. And that could be the flux, that could be the power source. They've already identified the problem when I get on site. And that's probably the most difficult thing. And I think Nate would probably say the same thing for a manual welding process. You show up on site and they already know what the problem is. And you have to kind of take a step back, because I like to say there are no ghosts in welding. There's a way to figure this out, but to articulate that in a way not to offend the customer and say, well, that's a good idea, but let's look over here. Let's take a step back. I mean, Nate, I'm sure you've got experience in that regard.
Yeah, that's probably, I would say, one of the most challenging things about what folks like us do. When you're the problem-solving guy and you're like, hey, this is the guy that's coming in to fix this. And they're like, well, we figured it out. It's definitely going to be the gas. And you're the guy that's got to be like, yeah, well, it could be the gas, show me what you're talking about. But you got to, like, it's really, I don't know even know what it is. I mean, I think it's just welders in general are really kind of hard-headed. I mean, it's just kind of that mentality. I mean,
hard-headed
I
and
hate
prideful.
to say that. Yeah, I mean, and I know that because I'm a welder, and if somebody was telling me how to weld what I'm welding, I would probably give them the same attitude. But being able to be this person that comes in and is able to make a change or get somebody to think differently, that's the biggest challenge that that I have like every single day. I mean, it's literally the biggest challenge that I have. Folks like David and Mark Fisher would be another example. Trying to get people to think differently or look at a problem differently. This is really the biggest reason why I wanted to have David on the podcast, is talk about somebody who's working at the highest level, still having exactly the same issues.
So what you're currently working on these battery boxes using lasers now. So you've switched from SubArc, which is really, really thick. You learned a lot about that process. And now we completely change everything and we switch over to a laser application.
Yeah. Yeah. And to be perfectly frank, when I got assigned this, I knew nothing about lasers other than like the cool little thing you get in school and point lasers at like the chalkboard. But how do you end up melting material with this, and how do you weld with it?
How do you do that? Because I don't know yet.
Well, we'll get into that, Nate.
Yeah, let's dive into that rabbit hole.
Wild.
Yeah.
But I mean, like the SubArc thing has been going on since, I don't know, 1930s, 1940s. And you can talk about constant current, constant voltage, DC positive, DC negative, AC, and all the kind of the variables in between. And so they've kind of standardized on advanced SubArc procedures, as I like to call it. So there is a best in class way to weld, best in class joint preparation. It's pretty well studied over the decades. Whereas electric vehicle battery trays, or just electric vehicles in and of themselves, or batteries in and of themselves, is like the Wild West right now. So if you don't know anything about making electric vehicle battery trays, let me make it really simple. But you basically get a bunch of AAA batteries. So think about your AAA batteries. You got a bunch of those. Those are called cells. So each one of those AAA batteries is a cell. Then you put a piece of copper on top of that, and you laser weld that. That's called and you get a bunch of these cells put together into a group. That's called a module. That module eventually needs to get put into a box. That box is called a battery pack. So it's really a 3-step process. So when you hear of all these gigafactories coming up and all these things, it's not really clear. Is it a gigafactory for cells, for modules, for packs, or for the whole supply chain? So maybe I'm getting a little too techie or dorky. I apologize.
Keep going.
I'm with you.
To kind of frame what does it mean to have a gigafactory, there's no standard definition today. But what you need to remember, there are 3 steps in making an electric vehicle battery pack. It's the cell to module, module to pack. And so I get dumped into this. I don't know any of this, let alone welding, let alone the 3 stages or how you do this. And they say, go figure it out. So over the last, 14 months, we've built 2 different prototype centers here in Europe where we can actually do some of these. And now, just to clarify, I'm focused primarily on the pack, so the box or the enclosure that holds these. Now, Lincoln, the company that I work for, they do everything from the cell to the module to the pack. But me in Europe, I'm focused exclusively on the pack. So we built prototype facilities where we can test this. And the way you make a pack between different OEMs is very different. So let me go back to my SubArc analogy. If you want to transmit oil and gas, you need a big round pipe. That's pretty obvious. And there's not a lot of deviation to that, whether it's 36-inch or 42-inch, it's a round thing. How you make these battery packs or battery enclosures is the Wild West. Some people are making it out of aluminum extruded tubes. Some people are making it out of channels. Some people are making it from cast aluminum. And it's all wide open.
So there's no specs. There's no standard way of doing it. There's no way to go out and do additional research and replicate and reverse engineer, because everybody's doing something different and nobody knows what's really the most effective and efficient way to do it just yet.
Right. And add on top of that, and this is an interesting little tidbit that I'll throw out there and borderline of how far I can talk about this, but all these large automotive people have created independent battery companies. in the interest, because in the automotive world, if you want to make any change, it takes 5 to 7 years. That's just kind of an industry standard. But we don't have 5 to 7 years to transition to electric vehicles, right? 2030, everything produced in Europe is going to be an electric vehicle, or maybe pushed to 2035, but still they have to move fast. So they've created these independent companies to make not only the battery cells, modules, but also the packs. So they've excluded that from the traditional company for the interest of speed and go to market. But what they lose in that is all the technical experience from the traditional, let's just use welding as an example, of the welding department of these automotive people. So it is a double-edged sword.
So are they building their own components and everything? Because like you equated it to like AAA batteries. So they're essentially building their own cells as well.
Some are. I mean, Google gigafactories. I mean, it's not just Tesla that comes up. I mean, Tesla's obviously a big one, but there are hundreds of these, and all investments are going into batteries. And are they all all of these AAA batteries are not going to end up in automotive? That just happens to be the large scale. But these same cells are going to end up in different batteries for your home or for your drills or different components in your life. But everybody's building these gigafactories. Some of them are fully integrated to the production line, to the OEM. And when I say OEM, meaning the manufacturer of the car. Some of them are just being sourced to different providers. So it's like the gold rush. What I would imagine the gold rush to have been 200 years ago in Nevada. Like everybody's out there trying something different, something new that they all think works.
Okay. So when you got put on this project and everything, it's not like you had a blueprint to go from. They were like, hey, we need to put these items inside of a box, like figure it out.
Yeah, it was more or less, we know that electric vehicles are going to be big. I work for a company that's publicly traded. We need to make money, obviously. So how do we capitalize on that? But honestly, as a 128-year-old company, I think we're more focused on doing the right thing for the customer. So how can we help them through this transition, whether it's directing them to standards, to codes, to easier ways of welding? I mean, I go from anywhere to being in the lab laser welding to sitting in front of code committees in a single day. Like the spectrum of what I get to sit in front of is why I love what I do.
It's constant change.
Yeah.
So when you started building these battery boxes, did you know that you were going to build them out of aluminum, or was there like another alloy to choose from, or just they said, here's the type of material we're going to make it out of?
I think long-term, everybody knows it's aluminum just from a weight perspective, and weight means longer range of these EVs. But the whole war in Ukraine caused supply chain weirdness, is probably the least political way I can say that. Is aluminum even going to be available? So then people started looking at galvanized steel, and maybe that, because all the automotive people are very familiar on welding steel and welding galvanized stuff, they're not so familiar with welding aluminum. So that was kind of like a hiccup in the adoption portion. And I think if I fast forward 10 years from now, we're going to look back on this blip and it's all going to be aluminum, just for pure economy of scale. But this situation in Europe specifically right now is definitely a blip to slow things down a bit.
Okay. Now, when it comes to the welding setup, was joint configuration a big concern? I mean, were you guys doing butt joints or like outside, inside corner joints? How did you determine what the joint configuration was going to be?
Well, again, when I came on board, I basically was asking, what do you want me to weld? How can I weld this? And so a lot of it was T joints, a lot of butt joints. And the way that we do it is very unique on the market, and then ran into some hurdles there and realized we needed to kind of pivot on how we deliver that laser beam to the weld. So instead of just a large square beam, we ended up going with like a spot and spot module, which, Nate, this is like weld science to the moon.
I'm like, keep
really,
we
really
want to know about the lasers.
Arm the laser.
Yeah. Tell us about this setup. So you go to one of your facilities, which someday I'm going to come out and visit with you. in person. So we go into one of these places where you work, and you have a laser robotic cell. Can you explain kind of what the components of that system is like, and what knobs do you have to play with that system?
Great question. So, I mean, first, to take a step back, when you have a robotic arc welding system, you have to have the curtains, right? Because there's safety involved. And that's important. And then I don't want to neglect that, but I want to highlight laser safety is like that times 10. So completely sealed off, not even an air gap. It has to be completely sealed off because we're working with high class lasers. So safety, number one. Two, very precise robots. So everybody thinks a robot always goes to the same place every time. That's not necessarily true because they're not perfect. Neither am I or any of you in welding. So you have to have a very precise robot. And then you couple on top of that a laser power source. So laser is literally the best description I ever got when I started was think of a flashlight focused down into a pinpoint needle multiplied by 1,000,000. Okay.
Yeah, it makes sense. Yeah.
So that's how I think about.
We're talking like regular Ryobi flashlight or like a Streamlight, Surefire.
Think of any flashlight you want. Focus it down to a pinpoint and multiply it by 1,000,000.
Damn.
Now I have to have a wire hit that laser. That laser has to be in the joint, and the joint has to have consistent fit up to make a good weld. Now, the unique thing about what Lincoln does is we add a unique wire to the process where we can bridge gaps and have a lot more flexibility. But one of these systems, I mean, just to put it in perspective, a standard system, you're probably talking in the ballpark of $1,000,000 before you did anything. Forget tooling, forget any of that. Just to drop in a laser plus a welding system plus fume plus safety enclosure, it's $1 million system.
Serious stuff.
Dang.
So you have I've only seen some of these things in getting a chance to kind of tour around the automation facility over at Lincoln in Cleveland. So I've seen just a glimpse of this. There's a power wave that's associated with this. It's specifically for the system. Can you tell us about that? I'm asking also for me because we've yet to have this conversation.
Yeah. So the cool thing from the traditional, and I always say arcs and sparks, because that's who I am. That's my nature. That's my background. But just fair warning to anybody listening: if you talk to laser people, they emit lasers. They don't strike an arc. So that's just kind of a jargon that they want to be sure to use. So when you transition from striking an arc to emitting a laser, there's certainly a different jargon and a different level of technology there. But what the power wave delivers to that is very unique on the market. So if you want to break it down, what's hyperfill? Hyperfill is a twin wire MIG process, right?
Right.
Other people have done twin MIG wire processes. It's actually, if you look back at old patents, it's been around since the 70s. But the way the power wave regulates twin wire MIG makes it hyperfill. It makes it special because of the waveform behind it. So if I use that same analogy for what we're doing, what we call precision power laser. So precision power laser is a hot wire laser process. Now, just like twin MIG is unique with hyperfill at Lincoln, our hot wire laser is very different than everybody else's. That's why we call it precision power laser, because I don't want to just be compared to somebody else's, not from a marketing standpoint, but just to be clear, if you look at other hot wire laser systems on the market, they only run between 100, maybe 120, maybe even 150 amps. So I realize I asked this not to be video recorded, and I'm using my hands to make gestures. So maybe, Nate, if you can orate how this looks. But we feed in a wire to the process that is hot. So other people feed in a wire, let's say at 150 amps. I give them the benefit of the doubt. 150 amps on an aluminum wire is just enough to get it like 5 seconds warm in the microwave, right? It's like that pizza that you're just really frustrated that doesn't taste good.
It's still cold inside. Still frozen.
It's really cold. Where our wire comes in at 500 amps.
Jeez.
That's a big
really
difference.
hot. Now, here's
Comes in like al dente pasta.
Yeah, no, this is not al dente. This is hot. The reason other people stop at 150 amps is because it breaks into an electrical arc. It starts MIG welding.
Okay, I see what you mean.
That makes sense. So it's kind of like a short circuit MIG with like a laser overlay, the way some of the other companies are doing it.
Yeah, exactly. And the way
kind of like TIG dressing over top of a weld.
Yeah, that's a good analogy, Jason. Yeah.
People understand that.
Yeah, you gotta tone down my dorkiness a bit, so I appreciate that.
No, keep it going.
No, this is what we're here
but
for.
the way we do it, so 500 amps, it's coming in. It wants to break into an electrical arc. It wants to MIG weld. I mean, that's pure physics. I can't change that. But if you understand power electronics and the speed of electricity, and that gets into a whole different discussion, Lincoln has a way, patented way, by the way, to suppress that arc. So we never break into an electrical arc.
Oh, that's interesting.
It's really super cool. And if
so it's
we're
just
on a podcast, I'd pull up a video
amps.
right now.
So it's literally just carrying carrying potential 500 amps inside the end of the wire. So it's not creating a contact. It's not going into a spray transfer. It's just like right there on the cusp, and
it's screaming hot,
emitting with a laser.
It's ready. It wants to be melted into a weld pool, right? It's ready to go. It's warmed up. And then that laser just comes in, gives it the little added heat, and just washes everything in. So it's a super smooth process. I mean, you can look it up on YouTube. It's public information. Precision Power Laser, really smooth looking welds.
Now you talked about the power source. You mentioned power wave, but I'm just going to go out on a limb here and say that a power wave for CC welding is not the same as the power wave for the laser, because there's obviously some different circuitry inside of the laser power source, I'm assuming. I don't know anything about lasers. That's why I wanted to get you on here and talk about all this stuff, because this whole technology is new.
Yeah, so let's separate.
All I know is like the light weld 215. Like that's really all I know about friggin' weld or laser welding.
So let's separate the welding equipment from the laser equipment just for a minute.
Okay.
The welding equipment is the exact same. So the R450 or the S500 that you have in your shop, you need additional module. I mean, that goes down to the power electronics and how we kind of circuit that. But from the power source standpoint, that plus this special little card, you can laser weld tomorrow. It's the same thing. That's what's so cool about the Power Wave, and I'm a little bit on my preaching pedestal from Lincoln at the moment, is it can do everything from aluminum pulse on pulse to cobalt nickel alloys to laser stuff. I mean, it's the same power electronics.
And we just arc gouged with my S500 the other day for the Power Wave video.
Yeah, and that's about as dirty as you can get.
Yeah. It can literally do whatever you want. Like, it's just...
I would hope so.
Yeah. It just, it takes power out of the wall, and it does whatever you tell it to do. And that's why I love it so much. Okay, sorry, continue.
Yeah, no. So that's the welding side, and that's where I kind of geek out. And what I've learned on the laser side, there's different laser manufacturers, there's different laser technology. There are inherent advantages and disadvantages to different lasers. So for this process, Precision Power Laser, we normally work with a company called Laserline because they make a direct diode laser. You shouldn't know what that means, other than the analogy that I like to use is it's a dump truck laser, or a work truck. Let's say work truck. It's big, it's heavy, it's robust, and it shows up every day. I mean, it's the boom work truck laser. Now, there are other lasers on the market that we do the same process with. I don't want to spit too many brand names out just for getting myself in trouble, but we can do this process with any laser. And there, again, if you need to have deep penetration or something very specific, other lasers might be better suited for this process. But in general, we like that large spot size. If I go back to the camera, because that large spot size gives us gap bridging capabilities. And if I go back to the arc welding world, where we're all familiar with, if you think about the arc cone, right? As long as the wire is inside the arc cone and the gap between the material you're welding is within the arc cone, you can bridge that gap and you can make a good weld. That's the same thing with this laser technology, as long as the gap or the bridge or the tolerance is within that spot size, you're going to make a good weld. That's why we like the big spot size. It's more forgiving. Now, most laser people like a really precise, really small, everything's like 0.001 millimeter gap tolerance. And then the Lincoln boys show up and we're like, nah, it's okay. Let's go with a 1 millimeter gap. We'll figure it out.
If I can step over it, I can weld it.
Yeah, exactly.
Yeah, fit up is like is such a like fit up and tooling and stuff like that, and any robotics, like just like you to your point before, like robots, they're people think that they're accurate, but in this situation, you're using an extremely accurate robot, and the tooling, like you said, to fit these parts up, hold them in exactly that position. I mean, it's difficult sometimes to get parts fit up the right way. I mean, stuff happens. I mean, there's a lot of moving small components that have to go together to make up one of these trays. And if you have a little tiny gap or something in something like, and you hit that with a laser and 500 amps of wire, it becomes a laser cutting robot instead of a laser welding robot.
Yeah, when you start cutting, that's bad. But I mean, to put in perspective, on that application, specifically I'm talking about a full skateboard, and skateboard is the battery tray that goes under the car. It's 2 meters wide. That's the width of the car, and it's 2.7 meters long. Okay, just to give you perspective, and I apologize. I realize this is an American podcast, but I'm stuck in European units.
Oh, it's everywhere.
People can convert. Awesome.
People across the pond are going to love this. Everybody else, you can download a converter app on your phone for free.
That's right.
Yes, please. So 2 meter wide channels, 2.7 meter long full car, 42 meters of weld on this project. One vehicle, 42 meters of weld. Just rough conversion, that's like 140 feet. It's a lot of welding. And the tolerance from corner to corner, Jason, was 1.5 mil. That's how straight it has to be.
This is where
how do you avoid distortion? Like, I mean, are you clamping everything? Do you have to pre-tack it? I mean, how is everything held together? And I mean, obviously you can't anticipate distortion, but after you weld a couple out, you kind of know where the bulk of it's going. How do you pin and tie everything down to, as you're welding on it, especially at 500 amps, this thing's not getting like ripped apart or just completely distorted?
Well, and I love that you brought up the 500 amps, because that's what everybody gets hung up on. But remember,
I mean, you're also traveling at 300 inches a minute.
So yeah. Wait a minute, you're getting a little too ahead of me here.
500 amps is not going into the part. Is what you're about to say.
All right, go ahead, Nate. Finish it for me.
So amperage is penetration, and amperage is part of the heat input. So heat inputs volts times amps times 60 divided by travel speed gives you kilojoules per. Is it joules per inch or kilojoules per inch? One of those two. But
kilojoules per inch.
Basically, because you're now pulling the amperage out of this equation. So amps times volts times 60. Amperage is, a huge part of this. Obviously, travel speed's a huge part of this. So you're pulling
the biggest.
Yeah, you're pulling the amperage out, and then you're also pulling, 300 inches a minute of travel speed versus
the
here I
amperage,
am.
Just to hit home a little bit more, Nate, you hit it 100%, but I'm gonna steal your thunder. That amperage is in the wire. It's not in the part.
Exactly.
So it's no longer a heat input in the part.
So it's not a variable anymore.
Right? Exactly. That's the wild part.
It's kind of like a preheat.
That's
for the wire.
Way to think about it. Yeah. It's a preheated wire.
Okay.
Yeah.
So now what kind of, I would imagine with a laser, what temperatures are you operating at? Because I mean, welding arc's 10,000 degrees Fahrenheit, roughly. But I mean, like, what temperature is a laser actually emitting at?
So, I mean, lasers are inherently cool. Like, you can put your hand under it. There's no temperature to it because it's light. What it ends up doing is heating up the base material, and you have to get molten aluminum or molten steel either way. So you cannot get around melting the base material. That inherently has to happen. But the idea behind what we're doing, or what Lincoln is doing, is heating up everything else around it so stinking hot that we just add a little drop of heat into the base material, and then everything flows together. So preheating is a good way to think about it. Another analogy could be brazing, which I don't like to use because then people go down the wrong path. But the idea is to get everything so stinking hot that you just have that one little droplet of heat from the laser and everything flows together. And again, we're using laser power in the range of like 12 to 16 kilowatts on a daily use. That's a lot of power.
12 to 16,000.
Now,
holy cow. Yeah, that's a lot.
What type of variables do you have when it comes to using a laser for welding? Like, I mean, everybody's familiar with, like, let's use MIG because it's kind of or TIG because it's the most complicated, as far as variables.
Sure.
Because you've got your amperage, you've got your pulse settings, you got your background current, you got balance, you got all this other stuff. What are some of the things you have to worry about when it comes to dialing in a laser? Because I'm virtually certain you can't just walk up there and hit the on button and, make it run.
Well, if you could, you wouldn't need me. But that's ultimately the goal is that you can hit the button. But traditional laser systems are used in what's called a hybrid process, hybrid laser. And we do that. That's easy. But in that process, you basically have a CV power source. So you have a MIG weld plus a laser. So you have wire feed speed, voltage, and laser power. What we're doing with precision power laser is very different. So we have laser power, we have wire feed speed, we have wire power. So now the wire feed speed and the wire power are now decoupled. Does that make sense? So I can send in more wire without power to it if I want to fill things up, or if I want to get more penetration, I can send in more laser power with it without increasing the wire power. So I have much more flexibility with this process.
So they're independent variables.
Yeah.
So now can you adjust those on the fly through a pendant, or do you have like a console or the front end of the machine that you can actually mess with that independently as it's performing the weld?
You can, absolutely. Again, running at 300 inches a minute or 8 meters a minute, you're not changing anything on the fly. So you need to know what that part looks like. I had a project a week ago that had different countersinks below the part. So different kind of channels underneath it. And we found out when you ran over these countersinks, you had to change the parameters. So I wasn't sitting behind a teach pendant saying, oh my goodness, there's a heat sink, please heat up. But I knew at 6 centimeters into the weld, I needed another 100 amps to make sure that I got the penetration because the heat was going to flow through that countersink. So you pre-program everything, but you can, of course, vary it as you're welding. Yeah.
Okay. Now, do you get into any of the testing? I mean, you're developing these procedures to figure out how to do this, reproduce the same results. I'm pretty sure you're working off some sort of WPS. But when you start welding these things out originally, before we figured out the formula, were you doing any like destructive testing, non-destructive testing, just to verify that, hey, we're actually getting the anticipated outcome on this. We're getting here's the penetration profile. Here's, the tensile pulls or anything like that.
Yeah. I mean, honestly, macros, tensile pulls, these are such small welds. You're not going to get a tensile pull. If I go back to Nate and some of his videos and like just taking a hammer to a hyperfill weld and like seeing if it has good tie-in to the base material, as stupid as it sounds, that's kind of what we do just to see initially, like you said, Jason, are we in the right direction, or is it just lack of fusion? We take a big hammer and we just hit it.
It's real technical.
Okay. Hey, if it works, it works. We busted a lot of welds together, and once you break it apart, you can see what's on the inside.
I know. It's like, I can't emphasize that enough. It's like we got, people doing absolutely cutting edge stuff. It's still 2 pieces of metal and a hammer. It's really all, a lot of times, like, I'm just happy that people look, If you haven't broken open one of your welds, like, maybe this podcast will inspire you, like, just take a look.
I just had the 1 week class that we did a couple weeks ago. I had one of the students, and I was like, yeah, so let me show you actually how this stuff works. So we were on short circuit MIG, and I was like, it's not recommended for anything over 5/16. Had one of the students, he'd been welding for like 2 hours. I was like, okay, go ahead and, weld out this 1/4 inch joint, put a 5/16 fillet weld in there. And I said, and then we'll do a destructive test on it. We'll break it. Well, I made a fool out of myself because he welded the thing up. I clamped it down to the table. I broke 2 clamps, and then I used like an off-brand version of can't twist. Like I brought in a new clamp the next day, and I was like, we're gonna lock this thing down. Now we're gonna pin it. We're gonna snap this weld. And this is 2 inch by 4 inch fillet, 2 inch by 4 inch 1/4 inch plate. 2 of them, just regular T joint.
Yeah.
clamped the backside of it, big crescent wrench on one side, still not working. Ended up and twisted that knockoff version of a can't twist clamp. And I was like, man, so we ended up trying to crank it down on the vise, could not break this thing. So I made a fool out of myself because I was like, yeah, we're gonna rip this apart, and then I'm gonna show you what's on the inside, see where you don't have fusion.
Yeah, I've learned to make sure that
full fusion.
I learned to make sure that I'm the person that's doing those welds when I'm like, this weld is going to come apart, and then I'll make the weld so that I know that it's going to come apart. Just like you stay on top of the puddle. I mean, like that kid, I think that's the thing about some of this stuff is like, yes, sometimes like, can you make it work? Absolutely, you can make it work. Can you short circuit on stuff that, yeah, it's not recommended for sure. But the one time you weld that thing and it doesn't work and it, becomes disconnected from your vehicle and becomes a projectile on the highway, that's when it's a problem. But, hey, if you, have him weld 10 of those things and try and break 10 of them, if 10 of them stay together, then he can weld that way as much as he wants. But if one of them, stays together and 9 of them just fall apart, that's not a good procedure. But yeah, anyways.
Yeah, you got to rewrite that. Yeah, so David, back to the laser stuff. When you're doing the laser stuff, are you developing a WPS or are you just writing a code into the robot?
No, it's 100% WPS. I mean, and look, laser welding has been around actually for like 40 years. But given the price point of laser entry to market, which has been coming down for so long, and again, you ask me like I'm a laser expert. I've only been doing this for a year, so I'm very much.
Oh, you know more than I do.
I'm still just breaking stuff, to be perfectly honest. But I do know that the laser price point has been coming down over the years, and I mean, Nate, you can attest to this more than anybody. That nothing frustrates me more than somebody saying that is too expensive. Whether it's the power source, whether it's the laser, because to me, it's not about that. It's what you, Mr. Customer, are trying to accomplish. Do you have 10,000 parts to produce a year, 1 million parts, whatever it is? What's your fit up? What's your tolerance? What are you actually trying to accomplish? Let's find the best tool to do that on a price per part basis, not a capital expense basis. Because look, if I talk to you about a $1 million laser system and you can go out and get a standard MIG welder at your local distributor for $1,000 that does 3 out of the 5 processes, you go, well, you're kind of crazy. Why are you talking to me about $1 million machine? Because that machine has a specific purpose and a specific place to be used. And that's where I like to talk about it.
Yeah, I think.
Well, yeah. And then, like you said, breaking it down per, what's the end cost going to be per part? If every part that you crank out is making you 90 cents and you're building 7 million parts a year, as opposed to the 600,000 you would be doing it manually, you're going to make your money back and then some at the end of the year, and the following year. I mean, depending on the volume and what that cost actually is.
Yeah.
It's like the old expression. It's like it takes money to make money. And a lot of people will, trying to solve a problem, they're like, we want to spend as little as possible. And it's like, well, like that's just not how innovation works. Like you're going to waste some money in the process. And that's part of the deal. Like you're going to break stuff. You're going to blow up some stuff. And if you're not breaking things or, finding out where the edges of that limit are, and you're just living in the comfort zone, you're not really moving forward. And this is really, this is the core of kind of, I don't know, the I guess like arguments I have with myself in my head. And it's like, not everyone needs to have a power wave and not everyone needs to have a laser. But, if you want to play in this space of trying to be cutting edge, you're going to have to break some stuff and you're going to have to spend some money. And that's totally okay because the reward on the other side of that is much greater than, the stuff that you break.
Yeah, I mean, you're knowing what your machine's actually capable of. I mean, you could stay in like a little safe space and run 100 inches a minute, but you're knocking out a third of your production.
Yeah.
We crank it up to 312 inches a minute. Now I can crank out, 3 times the amount of pieces. But you wouldn't know that if you didn't start pushing the upper limits of what those machines are capable of.
Well, Jason, that goes back to my previous statement of me asking a lot of stupid questions because somebody will say that's the limit or that's what we should do or that's where we should stop. And I'm like, well, why?
What if I just bump it up a couple more?
Yeah, let's break something. And I'm really glad that the video is not being recorded on this podcast, because I'm about to show you a picture that I can find that was about a $50,000 mistake that I made on the battery project. If I can find it here real quick. If not, I'll email it to you. But I basically asked the question, why are we stopping at 8 kilowatts? Let's double that. And they said, well, maybe we go to 9 or 10. And I said, no, let's double it. Because I think it'll be fun, and I think we'll get a good result. And we immediately broke about $50,000 in equipment, which is not a small sum to swallow, just to put in perspective.
No,
I mean,
no,
I don't
not.
have that money sitting around. I don't know about how much your podcast brings in, but 50 grand is a lot of money.
Much. Yeah, 50 grand is quite a bit. So did they tell you after the fact? We're like, yeah, let's maybe stick around 9 or 10, David.
Yeah. So actually, just for the sake of for you guys on the video side, so that's a picture of it.
Okay.
We literally blew up a quartz, a crystal inside the laser. Oops.
Gee.
But again, with our partners, we were talking to them. They said, hey, you were pushing the envelope. Did you learn something? I said, yes. They said, are you going to do it again? I said, absolutely not, because I'm scared you're going to send me the bill. But again, that's where innovation happens. That's where you try different things. Now, we backed off from 16, went down to 14. We changed a couple of things, and we got travel speeds. That's where we hit that 8 meters a minute, 300 inches per minute travel speed. That's where that was the precipice for that innovation.
So bumping it up 1 or 2 wasn't going to do it. I mean, doubling definitely was too much. So it was, you kind of found like a happy medium between the two to be able to increase productivity and still not blow up a laser.
I think we could double it again, honestly. But there are some precautions to take and angles and spacing and all that. But no, heck, give me a lab, or I'd even put one in my garage if Lincoln would let me. I'd double it again. I think we could do it.
You want to bet 50 grand on that?
Yeah, I probably would, actually.
Yeah. See, this is what I'm saying. This is where what I hope someday that I get a chance to do, is be able to like fund stuff like this. It's like, you know what? We're going to do it. We need like a weld science, like Bruce Wayne kind of lab where we can kind of push the limit without, where it's like okay to push the limit. We just need some partners.
All right, we're going to go ahead and take a quick commercial break. This segment of the Arc Junkies podcast is brought to you by Strong Hand Tools. They just released some new additions to my favorite table, the Rhino Cart. The new versions include a 4-foot by 3-foot hydraulic lift table, a 4-foot by 4-foot version, and a new 5x3 version for those bigger jobs. They also released the new E-Lift turntable that's 30 inches by 30 inches and can hold up to 660 pounds, spin 360 degrees, and is electric hydraulic powered for ease of use. All these new products and more are available on sale right now at stronghandtools.com/promo. Get a sweet discount and free shipping before this promo ends on September 30th. There's never been a better time to join the Strong Hand family. We're also brought to you by Everlast Welders. Are you looking to get into welding? Maybe you need to upgrade your current setup. Or possibly you need a better machine to turn that side hustle into a full-time gig. Look no further than Everlast Welders. They have a machine for every skill level and budget. My personal favorite is the Lightning MTS 275, a true multi-process machine that allows you to run stick, MIG, TIG, both AC and DC, flux core, and has spool gun capabilities. This machine is a beast. Check out the full line of multi-process machines and more at everlastwelders.com. And be sure to use Arc Junkies in the comment section at checkout to get that Freenova foot pedal and TIG torch when you buy any machine that comes with a stock foot pedal. Everlast Welders. Weld mean, weld green. Now let's get back to the show. So, David, with these different pieces of equipment, I know with everybody's familiar with the MIG machine, consumables, contact tip, nozzle. Is it very similar in a laser, or are these like non-consumable components we're dealing with? Unless we double the kilowatts we're cranking out. I mean, is everything pretty much buy once, cry once, or are these parts that we need to swap out because I guess the diodes get a little bit bigger or anything like that? They start to wear out?
Again, and I'm going to be a pariah in my new industry of laser people because they all think they're the prima donnas. And if I go back 10 years in my industry, The TIG welders were the prima donnas, and everything was mysterious and difficult and super expensive, and you had to have this super expensive consumable or whatever. But look, from the laser side, what I'm doing, it's all standard stuff, from standard contact tip to standard wire. There's no special wire you need to order. There's no special gas. I mean, I hate to say it, the gas people always like to sell special gases and tri-mixes and quad mixes. Forget all of that. This is actually really, I joke with our laser expert in the U.S. that he's a redneck laser guy. And those words shouldn't normally go together, but he very much, and he embraces that term. He's a redneck laser guy, and he's taught me what I know today, which is not super one-off, super exclusive, very hard to do. It's take these standard components, put them together, and we'll make it work.
Okay. Now, are you using a shielding gas with any of this?
Yeah. So there is
there's
CO2
lasers out there.
There's a molten puddle. The puddle is generally pretty small. So flow rates tend to be about half of what you would see in a MIG weld, just because, again, the puddle's so small. But there is, again, for aluminum, typically just argon. You don't need any special blends, or the gas people will tell you differently, and that's okay. They have to pay their bills too. But we tend to be just standard gas stuff.
Keep it simple.
Okay. Yeah, I would think that the flow rate would be a lot higher, though, especially because of the travel speeds.
Sorry, you'd think so, but because of the small puddle, no.
Okay. What kind of diameter of nozzle are you running your shielding gas through to be able to keep up with that?
Yeah, so I mean, our standard systems with a 5/8 nozzle, which I think in the U.S. is pretty standard. So what's that? 14 mil. I don't have U.S. flow rates off the top of my head anymore, but whatever you do with standard aluminum MIG, cut it in half, and we'll be good to go.
Yeah, typically, as per Charlie Cross and what I've seen, I'm saying 50 to 60 CFH for MIG welding on aluminum. So I would say
probably dropping it down somewhere around 25.
Yeah, 25, 30 maybe for the laser.
But even again, at that point, with what you're producing, it sounds arrogant, but the gas is irrelevant. The gas cost is nothing, right? It's all about running the machine. Even if I quadrupled the gas output, which I'm not, it doesn't matter. It's about the cost per piece that we talked about earlier, Jason, right?
Okay.
Yeah, I mean, this is an interesting thing to me, because I look at welding as just a bunch of individual variables, and you have like this battery tray that you have to weld out. And it's like, well, what variables are there? Obviously you have your material variations and, maybe a couple gaps here and there. It's like, how do you tailor a solution that's specific to making these as fast as possible? There's like I don't want to say like a right way and a wrong way to do it, but there's the fastest way, there's the safe way, there's the old way, and then there's like the way that's like, where you get one right out of, 1 out of 3 right, where you're like, well, I think we could double this, but we might break some stuff in the process, but it's like something to reach for.
Nate, I'm going to drop two statistics on you, and I want to watch your eyes as I do this. So first statistic is 90% of battery boxes or battery trays are produced in Asia today.
Yeah, 90%. Seems about right.
Not surprising.
So nobody in the world is making these other than Asia. The second one is I was actually at a European supplier not long ago that had a 120% repair rate.
Oh, my God.
Now, let that sink in for a minute, because when they told me that, I was like, wait, I don't understand. My brain hurts. How do you have 120% repair rate? Now, I'm going to test you live on the podcast right now. How do you get 120% repair rate?
It fails again and comes back.
Exactly. Well, Jason,
Nate, God,
you now owe Jason a thank you. He saved you on that one. Yeah.
Yeah. I'm just trying to think. I'm like, is it broken when it got there or what?
It was broken when they got there. They repaired it. It came back again.
Yeah. So what ended up happening was the components went into this automated assembly line, and they did the welding and put all the pieces together. And then the battery tray popped out of the assembly line. and there were two guys welding these little repair welds, and then the battery tray went back into the assembly line. So 100% of the trays came out of the assembly line, then went back in. So that's 100% repair rate. And then when it came out of the end of the assembly line, they had another 20% repair rate. So that's 120%. That makes sense. My argument to anybody in the world, whether I'm living in Dubai or Japan or wherever I've worked, doesn't matter, is do it right. Forget about speed. Do it right, and then you can scale speed later. And not many people get that. They're like, I want 120 trays a minute, or an hour, or I want 16 pipes an hour, or whatever it is. That actually doesn't matter, because if you throw out 16 pipes an hour that 100% need to be repaired, your productivity is zero. So
right.
Going back to the conversation of what is true productivity.
Yeah, that's a really good point. Rework counts, like it's not just how many, get across the finish line. It's like how many are done once they're done.
Rework costs 300% more than doing it right the first time. I mean, that's a statistical fact.
So I call that prime rate. The pipe industry kind of adopted that about 10 years ago. So prime doesn't mean that it doesn't need to be repaired. It means it doesn't need to be inspected or any post-secondary operations to it. So let's go back to my pipe world. If a pipe goes through production and nobody needs to inspect it manually, it goes through the automatic inspection and x-ray and everything, and it goes out of the factory, that is a prime pipe. Now, a not prime pipe might be a pipe that goes through production, but somebody has to physically go and inspect it. They might not need to repair it, but they still inspect it. That's an unprime pipe.
Okay.
But if you inspect it and it still goes out the factory and you don't have to re-weld it, that's kind of okay. The worst case scenario is an unprime pipe that you have to re-weld, right? But if you take the perspective of what is a prime part or a prime pipe, goes through the factory, nobody touches it, nobody re-looks at it, that's kind of the lens that I view production in.
Okay. Now, when you guys are doing this, are you operating 24/7, or is it like 8 hours a day or 12 hours a day? Like, what type of production are you getting out of? Well, I mean, obviously the laser's capable of 24/7 production.
Yeah.
But are you all running them 24/7?
Laser wise, yeah. I mean, EV stuff is the moon is not far enough away to project where we need to go. So yeah, once you get something that works, you run it 24/7, 7 days a week, 30 plus days a month, all year. Yep.
Now, are the laser systems? Oh, go ahead, Nate.
I was going to ask about, since you get to travel for work so much, I was curious about some of so you live in Germany.
Yeah.
I'm just curious about some of your favorite places to get a chance to go see. I don't know, not that we're going to shift gears with this, but I was just thinking about all these different types of problem solving places that you get a chance to go, and wondering about what, you must get to see some really cool stuff, especially like in these factories.
Well,
What
normally welding places aren't put in like the cool parts. Like they don't have a really good welding factory in downtown Paris, right? That would be cool.
That's very unfortunate.
Yeah.
But I've seen the world, and I love working for Lincoln. I love the opportunities they've afforded me. I've been around the world 100 times, if not more. I have my favorite places I like to go. I mean, I lived in Japan for 4 years. That was a soft spot in my heart. I always love going to Turkey. I always love going to Greece. There's a great pipe mill there that I like to go to, Southeast US. But honestly, Nate, outside of some really bizarre experiences, again, my passion is for people, which maybe is not the right message to put in a podcast for welding, because I like to travel for people, and welding seems to be my conduit to get there. Mm-hmm. It takes me around the world, so I go wherever welding takes me, but it's the people that I connect with, and I love pretty much everywhere I've gone, with very few exceptions that I will only say offline.
You were just in Africa helping some people out. Can you tell us about that?
Yeah.
How did that? Yeah, I did not know. I did not know that was going to happen until you sent me the message, and you're like, "Hey, by the way, I'm going to Africa to work on this project."
Dude,
you went to Malawi, right?
Yeah, Malawi. I'd bet $100 to anybody listening on this podcast they can't find where that is on a map without Googling it. But don't hold me to that. So disclaimer is void. No, so long story short, my first manager was a great guy, still is a great man. He founded a charity focused on supporting Malawi, which is a really, really poor country in the middle of nowhere, Africa. I wanted to get involved, so he invited me to do so. Everything from like building houses with bricks fired by like wood fire bricks to I actually flew down with a welding machine and your hood, Nate. And this is kind of the divine providence that kind of came around with this. Was 2 hours before I was supposed to go to the airport, the doorbell rang and some guy delivered a hood and he said, "You owe me $60." And I said, "What are you talking about?"
Oh no.
And he was like, "Well, the guy that sent it didn't pay duties." And I was like, "Well, I don't even know what I'm receiving at this point, but okay, I'll pay the money." And I opened it. Yeah. Honest to God, true story. I took it into my living room. I sat down with my wife and I was like, "This is awesome. I have Nate Bowman's original weld scientist hood." And she's like, my wife said, "You're such a dork." And I said, yeah, I totally am. But I'm taking this to Africa with me. So I flew down to Malawi, built some houses with them, but brought a welding machine with me that Lincoln provided at no charge. And that went to the hospital down there. And today I even got a message earlier this morning is welding up hospital beds. Like you think about welding like gates or handrails or things that are just kind of nice to have. No, this machine is welding up hospital beds like that. I don't know. For me, that's really cool.
How long were you down there?
It was supposed to be 10 days.
You're in Germany.
I had some travel troubles, so it was 8 days. But yeah, so I was down there for 8 days.
Okay, is that something you do annually or just like
that was my
periodically? Or
to be perfectly clear, it was my first trip. I mean, I just got voted on to their board of directors. I don't know, 6 months ago. So I'm just now kind of coming into my leadership role in that organization, but I expect to go down once a year.
Okay. Were you doing training while you were there? I mean, I've seen the photos of you kind of like welding up hospital beds and everything, but were you training the locals how to be able to do the same thing so that like after you're gone, they can
absolutely.
They can do repairs and fabrication?
I went to the local maintenance department at this hospital. And when you think of a maintenance department at a hospital, I'm not sure what you think about because I've never thought about it. But I mean, they have like one little corner that is like repairing electrical machines. They have one little corner that's literally like sewing sheets. They have one little corner that's doing electrical like light bulb stuff. And now they have one little corner that's doing welding stuff. And so like the head welding or the head maintenance guy, Wilson, I got to talking to him and he said he knew how to weld. And I said, well, that's kind of cool. Not that you need to be tested by me, but before I leave you with this equipment, I want to make sure you know what you're doing. So, I mean, he struck a bead, 60-13, push angle, kind of stitching the weld, total porosity inclusion, terrible weld. But again, the guy's never been to a welding school, so no fault to him. So I said, okay, look, when you have slag, you drag, and this is the angle you want to use. And with this electrode diameter, you're going to be between 50 and 70 amps, and kind of dialed him in a bit. Spent about, I don't know, 2.5 hours with him. Not enough. I mean, he's not going to be welding up water pipes anytime soon. But again, this is a country that the average wage is $2 a day. And to put it in perspective, I mean, one of my colleagues wrote in the comments section, like, why did you not build a welding table before you started building beds? Which was a fair criticism, right? Like we're literally welding in the dirt. But I don't think you or Nate or anybody can appreciate the level of poverty. I didn't appreciate it. And I've been around the world a lot. Didn't appreciate it until I got there, right? Like if you need duct tape, that's 3 days away. I asked them if they had a grinder. They said, here's sandpaper. I said, we need to cut these bands for the hospital bed. And they literally pulled out a hacksaw. I mean, Nate, when's the last time you used a hacksaw to cut anything?
Anything. Oh, man, I don't even know. It's been a minute.
I used one 2 weeks ago.
You used a hacksaw?
It was intentional. It was intentional. I was like cutting the threads and the head off a bolt.
Yeah.
Okay.
And I didn't want to have to I didn't want to bust out the portaband and all that stuff just to cut a cut. And plus it was small, and I had to like kind of do some accurate cuts. But yeah, I mean it's definitely not my go-to. But I mean, yeah, no, very similar.
Yeah, it's
like my time in the military overseas. Like you don't always have what you need, and you really don't appreciate what you have until you see others without it, or you don't have it yourself.
Yeah.
I mean, we take a lot of things for granted over here in the States. I'm sure same thing in Europe. Access to healthcare, like any healthcare at all, whether it's great, good, bad, ugly, whatever, any access to healthcare, fresh drinking water, the ability to Uber Eats, especially over here, like just food in general. I mean, these are things that a lot of people throughout the world go without on a daily basis.
Jason, I got a speck of sand in my eye. I was in a bricklaying competition with a local guy, and I'm like in steel toes and safety glasses and like hard hat, and I'm like totally safetied up. He's not wearing any shoes. He's barefoot. He's like outpacing me 2-1, and I get a speck of sand in my eye, which in all really serious situations is not a big deal until I realize, one, it's not coming out. It's been about 6 hours. It's still not coming out. And two, if I get a speck of sand in my other eye, I'm going to be blind in the middle of nowhere, Africa. And this guy's doing the same damn job without steel toes or anything, literally barefoot. And he's double my output. So, I mean, like life gets real fast.
Mm-hmm. Yeah. I think that's something that everybody should do is kind of travel around a little bit, see how other people live. Look at some of the things you take advantage of on a daily basis. I think there'd be a lot less complaining and a lot less, griping and stuff all over social media and, throughout the world in general. I mean, like you really don't learn to, or you have no appreciation for a lot of the things that we have until you go, like I said, you travel around, see other people that don't have, see them without.
Well, and I was there with the CEO of a woodworking company based in the Bay Area. And his whole idea was he wanted to send a bunch of equipment there so that they could build beds and like normal stuff. Until we realized, well, how do you charge the batteries for that porta drill or that like the infrastructure just doesn't exist. So if I can have any plug that's not related to Lincoln, the organization's called demonstratelove.org. I am going back next year. I cannot take 100 people just because I don't have the bandwidth. But if there's like 3 to 5 people that want to go, whether that's you, Jason, or Nate or Neoma, that'd be kind of a not great honeymoon, Nate. But stop over in Frankfurt. We'll make it good. But I would love to take some people down there because it's good people, skilled at their trades, knowing what they're doing, and making a difference.
No, that's really cool that you went down there and did that. So you're going to start making this like a reoccurring trip through like yearly?
Yeah. So I just joined their board, I think 6 months ago. Excuse me. And I'll make it an annual trip.
Okay. Yeah, my buddy Ryan Eubank, I guess he went down to, I'm not sure where in Africa, but he was down there training welders and stuff. So
Ryan, it's funny you bring up Ryan. Ryan is the first guy that taught me welding.
Oh, so you know Ryan? Of course you know Ryan. Why wouldn't you know Ryan?
Everybody knows who Ryan is.
No, Ryan's a great dude. But
I don't think Ryan remembers me, but he taught me to strike an arc. And
I don't think Ryan forgets anybody. Ryan knows everybody.
Yeah, and I'll never forget. I said to him, I have a college degree and I feel like I'm going to electrocute myself. And he said, get to work.
This sounds like
great
Ryan.
Advice.
Get back to work.
Yep.
No, so what do you have planned next? I mean, you went from, well, actually, I want to go back to the lasers for a minute. What's the thickness limitations on a laser system?
So that's every question is answered with it depends, right? That's the easy answer. So for the easy standard stuff, biggest thickness is 4 millimeters. And remember, that's the thinnest member. So if I have a 4 millimeter sheet to a 32 millimeter extrusion, I'm good. Anything above 4 millimeters, you end up needing a keyhole, which makes things more expensive, more complicated, but we can do it. But we've done laser welding applications up to 50 mil, so 2-inch thickness, no problem.
Oh, wow.
That's heavy duty.
I'd like to do a cut and etch on that.
Yeah, that's heavy duty.
It's probably, I would imagine it's very similar to like the, if you just use 100% argon with gas metal arc welding, you get that like really thin, long needle-like penetration profile.
Yeah, pretty much. And to go back to the laser technology, so for the thin stuff, we use like a square spot with equal distribution power across that spot. So think of like a super soaker or like your shower spray that when you get in the shower and the whole head is spraying down. And then if you have to get it more penetration or more focused, you change that shower head from the whole shower head to just focused in the center with a little bit on the outside. Does that make sense?
Okay, so you can kind of really diffuse it.
Yeah, that makes sense.
Okay.
I didn't realize that the light was like that you were hitting it with was square. That's pretty cool.
Yeah, I mean, there's a lot of ways to shape it, and the laser guys are going to give you a lot of discussion about beam manipulation and beam shaping, and they get super dorky on that. That's great, and there's opportunity and advantages to that. But for what we're doing, we just need I think I called it earlier, we need the work truck. We need the big, shows up every day, bulky, plows through the mill scale, heavy duty truck.
Wait, you can weld through mill scale?
That was my next question. We don't prep our material.
Well, what's your definition of mill scale? I mean, aluminum inherently has mill scale on it. I mean, that
true. Yeah, the aluminum oxide.
Yeah. So,
but yes,
it just goes right through it.
Yeah, burn it.
Just burn right through.
Just blast through it.
Oh man, don't listen to David. Prep your material unless you're welding with a 14,000 watt laser. Yeah, then you don't have.
If
you got $1 million laser, you don't have to clean your base metal. Yeah. But if you don't have $1 million laser, make sure you clean your base metal.
To be clear, I mean, clean and prepped and prepared is always better. I mean, no question. I don't mean to detract from what you guys are preaching or be the redheaded stepchild. No, not at all.
Hey, watch it.
just teasing, because everyone, like everywhere we go, no one wants to prep their material at all. Like they're like, why I don't want to grind any of that off? But it's like, well,
I don't have time to do that. Yeah.
Well, I mean, if you really want to get into nerdy weld science discussions, you can talk about laser absorption rates into base materials. That gets really nerdy really quick, and mill scale is not your friend. So, or oxide. And you can jump from like a 2% absorption rate to like a 15% absorption rate just by having clean base material. And while that may not sound like a big percentage increase, 2 to 15, if you think of a percentage wise, that's like a 700% increase of laser absorption rate.
Yeah. Yeah. I feel the same way about just like in just any general weld prep. I mean, you have that arc cone. It needs to be interacting with the clean base metal. I tell people you want parts of, weld part A, weld part B, plus molten metal touching both of those things, and then you'll have fusion. Anything else in that process is extra and is not what you want. If you can eliminate any of those extra things, things get way easier the less variables that you have. And scale.
I think you kind of quoted Dwayne Miller, our Lincoln's seismic guy. But what makes a good weld? Atomic closeness and atomic cleanliness. After that, anything else you add is an unnecessary variable.
That's very true. Smart.
I mean, you get like good puddle fluidity, and the puddle's going to flow a lot better if you take the mill scale and all that stuff off.
Sure. Yeah.
But I mean, if you're running that laser, I mean, you're zapping right through it.
I got a question. So let's say somebody's listening to this podcast and they want to do what you do. How what type of people, what type of path would fit, or what type of path could people take to get to where you are? Obviously, you started in SubArc, and your path was a little, convoluted. Maybe you didn't really wake up in the morning when you were 15 and say, "Hey, I'm going to go weld battery trays with lasers." But can you kind of give us an idea of like what that might look like? Because obviously this is something that's an emerging market. What might people do to get into this?
I don't know, Nate. What would somebody do to become the next weld scientist? To kind of throw it back on you, man.
I guess just study, keep read, and don't be afraid to make mistakes and ask questions. I guess that's probably my best advice.
I agree with that, and it's frustrating in one hand, because I'll go back to a quote that a man, and we've talked about this, Nate. One manager early in my career told me, "Don't be afraid of the fire. Go run headfirst into the fire and go fix the problem." And the fire is something within the company or within a customer or something that's not working, but go get your hands dirty, go jump on it, figure it out, try to make it better. And if you come out with soot on your hands or smoke inhalation or whatever, they'll figure it out. Like they'll make it okay. And I've lived my life that way. Whether it's with SubArc or lasers, it's just, I don't really know what I'm doing, but I'm going to go 100% because I don't have second gear. I don't have third gear. I've got one gear. My gear is go. And so when they say, go figure out laser welding for electric vehicle battery trays, I say, okay, so I go. Is that something I would recommend everybody to follow? Probably not, because that comes with a lot of challenges along the way. That being said, it's how I continue to live my life, and I think it's frankly the right way. So whether it's right, wrong, politically correct, difficult, easy, go find something hard and run 100% in that direction.
Yeah, you can't be afraid. You can't be afraid of like messing up or failing, and that's like I said it before. I mean, I think that's the core of like why we talk so much and why I wanted to get your message out there is that, so many people I feel in the welding industry are they feel like they're just stuck in this very stagnant place, but welding is so new that there's constant innovation. There's always new stuff that's happening in the welding industry, and there's always problems to be solved. We just need more people to be out there and be willing to, blow some stuff up or break something or fail. But a lot of people live in a safe space, and it's not always.
Yeah, I agree with that. And that's probably an easy way to live or a safer way to live. I mean, Jason, I'd love to hear your thoughts on this, but I mean, if I get fired tomorrow, so be it. My dad told me early on in my life, go do your best. And if I came home with a C on my report card, and he would ask me the question, did you do your best? And I'd say, yeah, I did. He'd say, okay. And if I came home with an A on my report card or a B plus, let's say, and he said, did you do your best? And I said, well, I probably could have done better. He would have been really upset with me.
More upset than you bringing home a C and trying your best.
Yeah. So go try your best. And if you fail, I mean, it's really easy to say, probably from my perspective, because I am more advanced in the industry, but don't be afraid to fail. Go break something. Go give it a try. Because honestly, if you're not doing that, do you really want to be doing what you're doing today?
Yeah, I mean, take chances. I love your philosophy. Like, it's okay to make mistakes. You're going to make mistakes, and like as we mentioned earlier, you're going to learn more from your mistakes than your failures. And I used to that was kind of like my graduation speech that I would give a lot of the students that when they're coming out of the program, I'd say go out there and fail forward. Failure. Like I've said, it's the stepping stones to success.
Yeah.
You're going to learn a lot more through failure, breaking things, trying to figure things out than sitting back and just always doing what works. I mean, that's the problem within this industry, is that's the way we've been doing it for 20 years. Everybody's afraid to try something different. And when you're the one trying something different, you get a lot of pushback.
But I'm talking to you. I mean, like, some nobody living in the middle of nowhere in Germany. I'm talking to you. I'm talking to Nate. Like, if this is not a testament to like some nobody that just breaks shit and figures out how to make it work, like, I don't know what is. And maybe that voice isn't loud enough, but that's fine. I'm just super humbled and honored. Like, I'm here having that conversation with two of the biggest names in the industry. That's so cool. So
yeah, I'm on the other side. I'm like, this dude is so rad. Like, if you only knew.
Exactly. I'm like, man, I'm going to be like David when I grow up.
That's how I feel. I was just like, this is what's so nuts about the welding industry to me, is like, I've, and in my relationship with Lincoln, and like, I don't know. I think David and I kind of both in the same boat. Lincoln's a big machine, and it's hard to feel sometimes like you're not like you're drinking the Kool-Aid, but Lincoln is just filled with so many people like David, Mark Fisher, Charlie Cross, Charlie LaRich, like, I mean, there's so many of these guys. Like Ryan Eubanks was a Lincoln guy. There's so many people that have this same mindset of just like go do your best and challenge the norm and that kind of stuff. So I mean, it's great to see people having success in that space, and having a company that supports that kind of thing. I mean, and it's not supposed to be a Lincoln commercial, but it's just, I've been in the industry for almost 20 years now, and I've yet to find another group of people that kind of have that same mentality and that same, I don't know. I don't really know what else to say about it. Just like, it's so refreshing, I guess, to have everybody kind of thinking in the same thing or in the same space.
Well, I mean, there are a lot of like-minded people. They're weld nerds. I mean, that's why I always like hanging out with, Charlie and all those guys. Like, I mean, hell, look at when we went to his house and we're like, you know what? So we went to Charlie. Have you met Charlie Cross, right, David?
Yeah, of course. Yeah, sure.
We went to his house after hours after the Skills USA competition just to go hang out. And it was Rush and Nate and I, and Scott Prince was there one night. And we're like, that Ziggle, that he bought this thing called a Ziggle for his kids. It's like kind of like a wagon meets scooter type deal.
On like casters.
And we're like, that'd be cool, but what if we built like an adult size version? And so the next night, Charlie went to the store, he got some pipe and everything like that. And we're cutting this thing up inside of his garage. And we invented like a new welding process. So we're using hot wire fed MIG while Rush is TIG welding, because the material, I can't remember exactly why we were doing that, but we were like, let's see if this works. And like Charlie's over there running the MIG gun.
Some huge gaps that we needed to fill. So we were running like the MIG welder, but Rush was TIG welding, and we're feeding like MIG while he was TIG welding, feeding MIG. It was pretty fun.
It was kind of like laser welding.
It sounds awesome.
Sort of. I mean, when you think about it, but it was a hot wire fed TIG welding process. A lot of variables in there, because you got Charlie's running one system, Rush is running the other, and Nate and I are over there saying, what do these dials do? Just spin it this way, spin it that way. But it works out. But I mean, that's the cool thing, and that's why I love the podcast, because it brings so many people together. Nate and I kind of talked offline. There's a lot of people out there that do this stuff. They just don't know that there's other people like them out there. I mean, there's a lot of people that keep to themselves at work underneath their hood because they really don't jive or connect with the people that are next to them, because they're not just as excited about welding as they are. So that's the cool thing about the podcast. They can plug in their ears and be like, oh man, there's a lot more weld nerds out there. There's a lot more people that really like learning the science of this stuff, not just pulling a trigger for 40 hours a week and then going home. There's people that go home and read spec books and code books, and they talk about this stuff online with their friends, and they go to conferences and seminars to be able to talk to people in person about this stuff and learn more. So I mean, it's really cool to have like this outlet and meet people from all over the world. I mean, hell, David, I got to meet you through LinkedIn because Nate made a post.
Yeah, well, I think that's awesome, and I don't think it should be overlooked how important that is. I mean, I remember sending you some messages, and Lincoln and B-Rad, and like I was in training with this guy, and the local welding thing, but what you're doing on a broader level of just interacting with welding people and making it a common conversation. And it's okay. And it's cool to dork out about welding. I mean, I think I sent you a text message before we started this. Like, I feel like I'm going on a first date. Like I'm very nervous. And this has been an hour and a half of just cool talking. That's important. And I don't think that should be overlooked.
Yeah, I told you it wouldn't be too bad. It's just weld nerds talking weld nerd shit.
I think that's the exact quote. Yeah.
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 Well, what else do we got? We're at an hour and a half. What do we?
No, I'm not giving up
okay,
yet. He said most people don't make it to 2 hours. So
yeah,
I want to start interviewing you guys.
Oh yeah, what questions do you have for us?
So,
I guess
Jason, you were an iron worker.
Yes.
I was very much in California, connected to the ironworkers. I don't want to get into the politics of do you like unions or not.
Yeah, I try to shy away from that too.
Yeah, rightfully so. Love and hate relationship. Probably edit this from the podcast anyways, but I really just want to ask you anyway. Tell me about that transition from ironworker to trainer to podcast to what are you doing, man?
I don't know. Well, so my problem is I've said it a bunch of times before on the podcast. So forgive me if you've heard it. I've got a hard time saying no. And it just seems like the more, I don't know, layers I peel back from this welding onion, the more opportunities arise and people they just reach out, So when I was doing structural steel ironworker, and I was happy. I loved it. I enjoyed it. I'd probably still be doing that now had I not had that conversation with my professor, and he's like, "Hey, we're opening a welding program. I want you to come teach it." No, I'm not interested in that. I'm out here, I'm hanging out with the guys, we're putting stuff up. We're building America out here, doing fun things. Why would I want to give that up and go sit in a classroom with a bunch of snotty-nosed little kids? Well, it turns out I was like I said, I had a hard time saying no. So I took that opportunity and I was like, I'll try it out. If I don't like it, I'm going to be right back here in the field with my tools and my boys. And, we're going to keep doing ironworker stuff. And I fell in love with it. And honestly, I was not passionate about welding in 2014 when I decided to get into education. I wasn't. Welding was cool and everything. I got to do it on a daily basis, but for, lack of a better term, it was work.
Yeah.
I'd still weld in the garage, do side jobs and stuff like that, but I didn't have that passion just yet. It wasn't until I got in the classroom and it's like, man, I really need to know what I'm talking about because I don't want to give these students any bad information. I want to set them up for success. They're relying on me to give them factual content. That's what I'm going to do. So that's when I started going down the rabbit hole of researching welding.
So how did you connect with Nate?
Oh, shit.
How did we connect?
Through Instagram.
Instagram.
Oh, Instagram. We were talking about, I think you had reached out. We were talking, when I was with weld.com, we did a video on different welding processes, why we choose one welding process over the other. And then Nate came on with some real scientific explanation about deposition rates and this, that, and everything. And I was like, yeah, but that's kind of not the direction we were taking it. Basically material thickness, how fast we got to crank out these parts. Basically why I would want to use one process over the other. And I think that just started us down a track of, talking about welding. And I was like, oh, this guy kind of likes the sciencey welding type stuff too. And
I think this was before I was the weld scientist,
quite a bit from there,
though too. I think at that time
it was
early. That was early on when, I think I probably was still working for Airgas even at that time, maybe, or maybe I had just left or something. But I remember, you guys were comparing flux core versus MIG versus stick welding. I think if I remember right. Yeah. And you were like, which process is faster?
Because I need to be properly dressed for this conversation.
He's got the
weld science. It's so sick. But I think that, so I had reached out and I was like, hey, I'm like, you guys did this comparison, but your weld sizes are different, or, MIG, the MIG welding process, you compared 035 solid wire versus 045 flux core versus stick welding or something. And I was like, wait a second, there's too many variables here. The dep rate of the flux core is higher than the dep rate of the solid wire MIG because your settings are different and the diameter is different. And at least Jason was like, nice enough to go down the rabbit hole, I just was like, but the experiment is wrong, you know? And I'm like, you know, so yeah, that's kind of, I think, how we linked up. And then when he made the transition into to the, you know, the Arc Junkies podcast, I had been on with the previous host a ton of times. And then when you made the transition, I ended up coming on a ton.
Yeah. I always, like we mentioned earlier, you know, like I enjoy having you come on here because we get to kind of take that deep dive into the rabbit hole.
And we're going to do it more. I think since we were talking offline, I think we might do a weld science segment. I've been considering starting my own podcast, not because I want to start a podcast, but just because I enjoy so much the opportunity to be able to go down the rabbit hole. So we might be working on something like that.
Yeah, there could be a collab cooking.
Yeah,
coming in the near future.
This is the segue into the collab right here. Like we just have.
Yeah, we'll have to iron out some more details and stuff up at FabTech.
Yeah,
I feel like a third wheel on a date right now. But if I can lube the interaction a bit,
well,
if you guys ever want to talk anything weird or laser stuff or SubArc stuff, I'm happy to be the lubrication that brings you two weirdos together.
Well, like you were you're the glue that holds this together. Like, you know, you were like, hey, I'm not really sure about going on this podcast. And I messaged Jason. I said, hey, you know, what if I came on too? And he's like, yeah, we just have you both on. And I'm like, well, that was way easier than I thought. You know?
Yeah, no, definitely. I mean, especially since you guys had some background, and I mean, you've obviously had a lot of chit chat back and forth and, you know, exchanges. I mean, you guys know each other pretty well.
Yeah.
The weird thing is we don't. I mean, to be frank,
it's like, yeah, I was going to say, I'm like, I learned a ton. I probably learned the most about David on this podcast, actually.
Oh, well, fantastic.
Yeah, I think I learned the most about you, Nate, last time we talked, and your fiance picked up the phone, and I was like,
right.
"Whoa, that's weird." But
that's right. Yeah, we were in the car. Yep. She knows all about you, just like you know, she rolls her eyes when I'm like, "Oh, it's David. He's gone." You know. So.
Well, yeah.
You get all googly eyed.
Yeah. Well, when I opened up that hood and I brought it to the dinner table, but my wife was there, and I was like, "This is from Nate. This is the original hood," and she went, "You're so weird." And I said, yeah.
She doesn't understand
that hood. So the story about I'll tell you guys quick the story about that weld science hood. So I had given away all my, like, Lincoln will send me hoods or we'll do an event or something like that, and I'll have hoods or something. And typically I try to give hoods away to people that need them. You know, whether it's a student or, you know, a guy in a shop or something like that, or people have gotten hoods stolen. And, you know, if I have a spare hood, which I have quite a few of them, I'll typically just, you know, pass them on. So it was the second weld science episode. It was the one where we did donuts in the welding truck. And I typically try to wear a Lincoln hood in all my videos. You know, if we're shooting a video for Lincoln, that's just such a prominent thing. So I try to make sure I have a, you know, Lincoln hood on in the video. And the only hood that I had left was this like super plain Jane 3350, just a matte black. Like that's the only one I hadn't given away. So I took this big weld science sticker that's a replica of the Weird Science logo from the movie and from the 80s.
Great movie.
Yep, great movie.
Yep.
So I had someone Photoshop this Weld Science, Weird Science logo. And I just slapped it on the side of the hood, just basically to kind of get me through this video. We released the video and people were like, this hood is so cool. And everybody really liked it. So I just kept wearing it. And this was also kind of at the start of like the Weld Labs tour, going out to all the schools and visiting, and doing, you know, welding education for people. So the hood kind of became the face and the symbol of just going out and you know, trying to help people out. And David is really the I mean, I just thought I did not know that you were going to Africa to go help weld hospital beds together. And that is just such a cool thing that it ended up at your house right before that. You know, I just wanted to pass it on to somebody that I thought was making changes in the industry, and you know, it symbolizes you know, those changes. And I think it's a pretty powerful thing to see it, you know, welding hospital beds together in the middle of nowhere, you know.
Well, the
Kinda
fact
cool
that
how
it
that showed up
arrived
2 hours
literally
before
2
you
hours
went.
before I left.
Yeah.
You can talk about religion or divine intervention or whatever, but like 2 hours before I was ready to go, this arrived. And then getting down to Africa and welding that up, it was awesome. It was just really cool.
Did you get any superpowers from it?
I'm still testing, still looking for them.
Did your welds get better?
Actually, I mean, and perfectly to be full disclosure, I hadn't stick welded for I think 13 years, and I struck my first arc at 60-13, 3/30 seconds, so nothing special. Ran a straight bead and it worked, and I said, you know what, to the guy Wilson that I was training, I said, this is what you need to do, and I didn't strike another arc because I knew it was only going to get worse.
You welded one arc.
And on a high note.
Well, sweet, man. I don't know. Do you have any more questions for us?
Are you asking me?
Yeah.
Well, I guess I've turned interviewee to interviewer. Nate,
the tables have turned.
Yeah, I'm just like I'm literally a pig in shit. Please edit that out, because I'm just loving talking to you guys. But I mean, you guys have so much more influence on the industry than somebody like I have. And so, Nate, I mean, I know your contract with Lincoln, and we've talked about this, but you're not just a Lincoln guy. You're a welding guy.
Yes.
What's your next move? How do you, for lack of better term, level up? And just to be clear, Jason, none of this goes on the podcast. You have to edit this out because I am asking some. You can leave
this in because like I don't feel like I'm gonna give away any secrets, and if someone wants to try and do what I'm doing, more power to them. I wish there was a million weld scientists out there, and if there's anybody else that wants to do what I do, please call me and I will help you on your journey to do what I'm doing, because much like what you do, what I'm doing sometimes can be disruptive to the industry, and being the person that's questioning what people are doing and asking that why do you do it this way? Why are you doing it that way? And almost demanding these answers that sometimes can rub people the wrong way. So what am I doing next? My goal is to create 5-day, 10-day, and 10-week specialty welding courses for more advanced stuff. And, and partner with people like Jason with Underground Metalworks, partner with, any welding school that already exists and add a technical component to that program. And it doesn't have to be based in Lincoln stuff. I mean, it could be any machine, it could be any brand. But just, hey, here's what the data is. Here's what the knobs do. Here's how you check your work. Here's how you create a welding procedure, and here's how you use that. And it's just figuring out how to integrate these like smaller trainings and focus trainings into different schools and different programs and places that will host that sort of thing is really the next plan. So the Goodwill thing, going and doing a 3-day training for them, was kind of the pilot to that. And that was really successful. We took people that had never, ever, ever welded before and helped them kind of build some skills that could get their foot in the door at a company. And I think that for a lot of people, that's all that they really need, just enough to get themselves in. And then if you have that mindset that you want to continue learning, then you can take a specialty class in a specific process rather than learn the entire history of welding.
So maybe a bit of a softball, and I know Jason has a hard stop here in 9 minutes. I feel really weird hijacking the podcast, asking the questions. But
no. This is what it's all about.
This is great.
You guys love welding as much as I do, or at least it seems that way. Automation is clearly the future. Mm-hmm. I mean, we just don't have enough people that want to strike an arc, let alone all the other things that need to be manufactured. What's your take on automation adoption rate? Is it taking jobs? Is there a future? What's your take on the whole Cobot, robot, future automation, and I'll just shut up from there.
I'll say, like, from my perspective, I would say automation is actually creating jobs. If you have a robotic cell that goes in, typically you're going to have at least 2 or 3 people in order to support that system, at least, to keep it feeding at parts. So the whole, oh, well, it's going to come take my job. It's like, well, if you learn how to run a robot or a piece of automation, you actually have a ton of job security. And it's not taking your job. It's just making you not the person that's putting the weld in. You're just managing a system. And then on top of that, you may also have to manage the logistics of feeding that system. So you could have a parts guy, you could have somebody doing all the fit up, you could have someone doing, the finishing work after this, comes out. So I actually I'm seeing real-time automation creating jobs. At Central, my day job, we have, I think, 3 or 4 different robots. So I think maybe 3 cobots, different brands, and then a robotic cell. And it's taking myself, my counterpart Blair, my counterpart Todd. It's taking all of our collective knowledge to be able to learn and understand this equipment. And it's a new challenge for us. So I think that automation is coming. It's definitely inevitable. But you have to understand what the knobs do in order to understand and appreciate automation. And I think that's why I'm trying to get into that space of being able to help educate people on what welding variables are, how do you measure productivity, that type of stuff, so that you can really see the value in those things. That's what I got.
Yeah, I mean, if you think about it, you need to continue to advance. You can't rest on your laurels. You can't say, okay, I've reached the pinnacle of my career. This is what I'm going to keep doing the rest of my life. You have to be able to adapt, especially with new technology coming in. I mean, we talked about robots and cobots, but there's also additive manufacturing, and some of these systems are also incorporating artificial intelligence. Mm-hmm. But like Nate said, I mean, you still have to be able to understand these different variables. So I think it's going to attract a lot more people that were apprehensive or hesitant to get into welding because they're like, oh yeah, that's a plan B, or I just don't want to get into that type of work and, do manual labor. Okay, well now you don't have to, because everything's done on a teach pendant or an iPad, or, you just have to be able to convey that. You got to be able to talk to the robot and say, here's what I need you to do. But you have to have a good fundamental understanding of, like what Nate said, what the knobs and dials and switches and all that stuff do, all the different welding variables. So I don't think it's going to get rid of jobs, because we're still going to need people out there, like physically doing the work, erecting steel, welding things together out in the field, repair work, custom work. A lot of that stuff, you're not going to incorporate artificial intelligence or robotics or cobots into that stuff, just because it's actually faster to do that type of work manually. So I think there's always going to be a need for manual welders, but robots and cobots and automation and all this, it's going to create a different avenue. Like Lincoln has that big career tree. Once you get out of welding school, you can get into sales, you can get into repair, you can get into weld engineering, you can get into inspection, fabrication, all these different types of industry. It's just one more branch on this tree that we can now get into. I don't think I'll see, the end of welding in my lifetime, not manual welding. I don't think my kids or grandkids will ever see the end of manual welding. We're still going to have to hit that demand one way or another. Automation is just going to be, it's just going to help us get there a little bit quicker. It's going to help us be able to maintain the demand that what we have to do to get everything done.
Yeah, I agree completely. And I'm not supposed to talk about numbers at all, but for legal reasons. But I mean, stick electrode still exists and is a big portion of our business for a reason. Mm-hmm. So I agree completely. I don't see, and I'm glad you kind of both of you confirmed that you don't see it as cannibalizing on the traditional welding world. It just augments it to something bigger. And maybe my career is kind of unique because I'm not a job shop welder. I'm not even an inspector. I'm not even a welding engineer for that sake. I just happen to be the guy that never said no and always challenged things. And it took me to do new and different things around the world in the welding industry, and I've loved every minute of it.
It's a lot of fun. It has that effect on people. Don't say no. Just say yes to different opportunities. I mean, as long as it's a good thing.
Yeah.
Say yes to opportunities. You never know what opening one door will lead to.
Yeah.
Well, awesome. Before we get out of here, Dave, why don't you tell everybody where they can find you?
Look me up in Lincoln Electric, LinkedIn, D Kilburn at lincolnelectric.eu. Shoot me a note, send me an iMessage, WhatsApp. Yeah, I'm not a very social media person kind of guy. So if you can't find me, connect to Nate, and he'll connect you to me.
Yeah, LinkedIn is definitely probably the space for David, for sure. You do have Instagram, but you're kind of on there as a spectator, not necessarily.
That's more personal.
Yeah, exactly. Yeah, that's why I was. Mm-hmm. Yeah, probably LinkedIn is going to be the best bet for sure.
Yeah, and I'm happy.
Where's everybody able to find you at, Nate?
Sorry, go ahead.
Oh, go ahead. No, you're good.
I was going to say, I'm happy to connect with anybody. I mean, from laser welding, electric vehicle battery cells to hospital beds in Malawi. I'm going to a job shop tomorrow on my way to vacation to help somebody troubleshoot their 300 amp TIG machine. So if you haven't figured it out by now, I do it because I love it. And I would love to connect with any of you guys. Both of you, you're always welcome at my place here in Germany or in Europe. Would love to kind of show you what we're doing here more on the ground.
Okay. Nate, where can everybody find you?
Instagram at Weld Scientist, YouTube at Weld Scientist, and of course on LinkedIn at Nate Bowman.
Awesome. Well, gents, thank you for taking the time out of your day. I know we had to do a lot of coordination due to 3 different time zones, so I appreciate y'all being able to make that happen so we could get this information out to the masses.
Thank
you. Thanks for setting this up. Really cool.
Oh, anytime. It's my pleasure. I really enjoyed talking with you, Dave. Well, you too, Nate. I mean, we chat all the time, but yeah. Dave, it was a pleasure meeting you. Hopefully one day we can link up in person.
Absolutely. Would love to. Thank you, guys.
All right, everyone. Thanks so much for downloading this week's episode. I hope you all enjoyed the conversation. Be sure to subscribe on your favorite downloader app so you never miss an episode. I've got a lot more great episodes heading your way. I hope you all have a great rest of your week. Stay safe out there, and until next time, make every weld better than your last.